Hello everyone, I am Dr. Saida Aisha. In this unit of the Chemistry of Transition Elements, which is prescribed for the third semester BSc students, and in this session, I would like to explain what is the position of the transition elements in the periodic table and the electronic configuration of transition elements by taking 3D, 4D and the 5D series. So before going on into the transition elements, let us have a quick picture of the periodic table. As we know that the periodic table consists of 4 different blocks of elements, which are the S block, P block, D block and the F block. The elements which are present in the extreme left of the periodic table, that is the elements of group 1 and group 2, belong to the S block, and the elements which are placed in the extreme right of the periodic table starting from group 13 up to group 18 are under the P block elements, and the elements between the S and the P block are called as the D block elements or the transition elements, that is from group 3 to group 12. The elements which are placed below the D block elements are called as the F block elements. How are these transition elements defined? They are defined as the elements in which the differentiating electron or the valence electron or the outermost electron enters the n-1 d orbital of the n-1 main shell. They can also be defined as the elements which have incompletely filled d orbitals in its ground state or in its oxidation states. These elements are also known as bridge elements because they act like a bridge between the S and P as they lie between the S and P block of the periodic table. Because the last electron or the differentiating electron or the valence electron in these elements enters the d orbital, these elements are called as the d block elements. The d block elements are called as transition elements because their properties are intermediate, that is, they are in between the S block and the P block elements of the periodic table. And the elements starting from group 3 up to group 12 belong to the D block elements. So according to the definition of D block elements, they are the elements which have incompletely filled D subshell. But elements like zinc, cadmium, mercury have completely filled d orbital. That is, zinc has 3d10 configuration, cadmium has 4d10 configuration and mercury has 5d10 configuration. But these elements, that is zinc, cadmium, mercury, resemble a lot in the properties with the D block elements, and so they are studied under this block to maintain a rational classification. The D block elements are called as transition elements because they show a transition or a change in the properties from the most electropositive S block elements to the less electropositive P block elements. As we know that the D block elements are placed between the S and the P block in the periodic table, and when we move from left to right in the periodic table, the properties of the transition elements change from ionic, which are present in the S block, to covalent, which are in the P block. The transition elements have 10 groups. that is from group 3 to group 12 and 4 periods, while the fourth period be incomplete. Transition elements in the periodic table include the 3D series or the first transition series, which consists of elements from scandium with an atomic number of 21 up to zinc, which has an atomic number of 30. The second transition series is the 4D series, which consists of elements from yttrium with an atomic number of 39 to cadmium with an atomic number of 48. The third transition series is the 5D series, which consists of elements from lanthanum followed by hafnium with an atomic number of 72 up to mercury, which has an atomic number of 80. The last transition series is the fourth transition series or the 60 series, which has elements from actinium with an atomic number of 89 followed by rutherfordium with an atomic number of 104 to copernicium with an atomic number of 112. The members present in the 60 series are radioactive and do not occur in nature. Means these elements are artificially made in the laboratory. The next property of transition elements to be included in this session is the electronic configuration of transition elements. The electronic configuration of an element is a property which is characterized as an arrangement of electrons in the orbital. So the general valence electronic configuration of transition element is the configuration of an inert gas n-1 d 1 to 10 and ns 1 to 2. n-1 corresponds to the inner shell, whereas n is the highest principal quantum number of an occupied orbital in that atom. Also, we can observe that the filling of d orbitals takes place after the filling of s orbital of the next higher shell. So when we consider the electronic configuration of 3D series, which starts from scandium with an atomic number of 21 up to zinc, which has an atomic number of 30, the electronic configuration can be written as argon 3D 1 to 10 4s 1 or 2. So for scandium, the electronic configuration becomes the configuration of argon followed by 3D1 4s2. Titanium with an atomic number of 22, the electronic configuration becomes argon, configuration of argon 3D2 4s2. Followed by vanadium, which has a configuration of argon 3D5 3 4s2. Chromium has a configuration of argon 3d5 4s1 instead of argon 3d4 4s2. Manganese has a configuration of argon 3d5 4s2. Iron has a configuration of argon 3d6 4s2. Cobalt has a configuration of argon 3d7 4s2. Nickel has the configuration of argon 3d8 4s2. Copper has the configuration of argon 3d10 4s1. Zinc has a configuration of argon 3d10 4s2. The configuration of chromium should have been argon 3d4 4s1 and the configuration of copper should have been argon 3d9 4s2, but they are less stable. So we will write the configuration of chromium as argon 3d5 4s1, similarly of copper, which is argon 3d10 4s1. The electronic configuration of chromium is argon 3d5 4s1 instead of argon 3d4 4s2. Similarly, the electronic configuration of copper is configuration of argon 3d10 4s1 instead of argon 3d9 4s2. This is due to the additional stability gained by the atom when the d orbital is half filled, that is 3d5 in case of chromium and 3d10 fully filled in case of copper. One electron from the lower level, that is the 4s level, jumps to the higher level 3d level in order to gain extra stability. As it is evident, there is exchange of electrons from the 4s to the 3d subshell, thereby increasing the stability of the valence shell configuration in chromium and copper atoms. Thus, we can say that among the 3d series elements, only chromium and copper exhibit irregular or anomalous electronic configurations. Similarly, in the 4d series, molybdenum has a configuration of outer electronic configuration of 4d5 5s1 and silver has the outer configuration as 4d10 5s1. So in higher elements, the energy difference between the n-1d orbital and ns orbital becomes smaller and hence the electron can jump from one orbital to another orbital. Thus, there is an irregularity in the electronic configuration. These are some of the references what I have referred for the preparation of this session. Thank you.